Enterprise Service Bus B is a software architecture model that facilitates communication between different applications within an enterprise. Imagine a large organization where various departments use different software systems. ESB acts as a middle layer, enabling these diverse systems to talk to each other, even if they were not designed to do so. It ensures that data flows smoothly across systems, regardless of their underlying technologies or protocols, B works. ESB functions as a centralized platform where it connects and routes messages between various services, applications, and data sources. It uses middleware, software that provides common services and capabilities to applications outside of what's offered by the operating system to manage these interactions. When an application needs to send or receive data, it sends a message to the ESB. The ESB then takes responsibility for delivering this message to the correct destination, handling any necessary transformations or protocol changes along the way. This reduces the complexity for developers, who no longer need to worry about how different systems interact with each other. Hash key concepts associated with ESB. Service-oriented architecture, SOA. ESB is often a core component of service-oriented architecture, SOA, a design approach where software components are provided as services to other components via a network. In SOA, services are independent, reusable, and can be combined to create more complex applications. ESB facilitates SOA by ensuring seamless communication between services. Message routing. One of the critical functions of an ESB is message routing. When data is sent from one system to another, the ESB determines the appropriate path based on the message's content or other predefined rules. This ensures that data reaches the correct destination without the need for direct connections between every application. Data transformation. Different systems often represent data in different formats. ESB handles data transformation, converting data from one format to another as needed. For example, an ESB might convert data from XML to JSON, ensuring that the receiving system can understand and process the information correctly. Protocol mediation. ESB also supports protocol mediation, allowing applications that use different communication protocols to interact. For instance, one application might use HTTP while another uses FTP. The ESB manages these differences, enabling seamless communication between the systems. Service orchestration. ESB can handle service orchestration, which involves coordinating multiple services to accomplish a specific business process. For example, in an e-commerce scenario, an ESB might orchestrate services related to inventory management, payment processing, and order fulfillment to ensure a smooth transaction. Real-life use cases of ESB. In a large retail company, there might be different systems for managing inventory, processing orders, handling customer data, and managing finances. These systems often use different technologies and data formats. An ESB can connect these disparate systems, ensuring that when an order is placed online, the inventory system is updated, the order is processed, and the financial system records the transaction, all in real time. Healthcare. In healthcare, patient data might be stored across various systems like electronic health records, EHR, laboratory systems, and billing systems. An ESB can integrate these systems, ensuring that patient data is accessible and consistent across the organization. For example, when a doctor orders a lab test, the results can be automatically updated in the patient's EHR, and billing can be processed without manual intervention. Banking. Banks use ESBs to integrate various applications, such as customer account management, loan processing, and fraud detection systems. When a customer applies for a loan, the ESB can orchestrate the necessary processes, such as checking the customer's credit score, validating the account details, and initiating the loan approval workflow. Benefits of using ESB: scalability. As businesses grow, the need for integrating more applications and services also grows. ESB supports this growth by allowing new services to be easily added to the existing infrastructure without disrupting the entire system. Flexibility. ESB offers flexibility by supporting various communication protocols and data formats, making it easier to integrate different systems regardless of their underlying technologies. Centralized management. ESB allows for centralized management of all communications between services. This simplifies monitoring, troubleshooting, and governance, leading to more efficient IT operations. Conclusion: ESB is a powerful tool for organizations looking to integrate various systems and services into a cohesive architecture. By handling message routing, data transformation, protocol mediation, and service orchestration, ESB simplifies complex IT environments. It enables different systems to communicate seamlessly, supports scalability, and provides flexibility, making it a cornerstone of modern enterprise IT infrastructures. Whether in retail, healthcare, or banking, ESB plays a crucial role in ensuring that all parts of an organization work together efficiently.